In this video, I'm going to show you how to discover the source IP address of an ATSC 3.0 broadcast and its corresponding port, and the destination multicast IP address and its corresponding port for an ATSC 3.0 broadcast. We're going to need an HDHomeRun that is capable of tuning ATSC 3.0 broadcasts. You're going to need the firmware to be updated to be the development version, and we're going to need Wireshark. So if you don't have Wireshark, download the latest version of Wireshark that's available. Okay, I'm going to launch Terminal on my Mac. You can do this on Mac, Linux, or Windows systems. And I'm going to type in wget http. Now, if you have more than one HDHomeRun device on your local network, you can type in either the assigned alphanumeric name from the HDHomeRun, or you can type in the IP address directly. But in this case, since I just have one on my network, I'm going to type in HDHomeRun.local, and we're going to use a port of 5004/auto. So for a virtual channel, what I'm going to do is choose 106.1. It's one of the channels on the WTVJ ATSC 3.0 Lighthouse. For duration, since we're just looking at IP addresses, nothing else, I can do a duration of like 10 seconds. We're going to type in AND format equals, we're going to save it as an ALP PCAP. So we're going to type in ALP and then PCAP. Okay. And as you can see here, it's capturing the file. Okay, and it's been saved. So now we can find it on our system. Okay, here's the file. And what we're going to do next is we're going to open up Wireshark. Okay, just get the latest version of Wireshark, and we're going to drag and drop the file into here. This is the packet capture interface in Wireshark. There's two protocols here. There's ALP, which is the ATSC link layer protocol, which is based off of UDP. And then there's ALC, which is the asynchronous layered coding protocol, which is also based off of UDP. We have our source IP address and our destination IP address. Now, the reason why I picked on the WTVJ Lighthouse first is because they really should not be doing this. Their source IP address is the IPv4 loopback address, which is the 127.0.0.0/8 block. If you know IPv4, that is supposed to be a loopback address, and they're not supposed to be using that, but technically it doesn't matter since this isn't being implemented on any sort of wider network infrastructure than just this ATSC 3 station. But for their destination IP address here, so you can see there's different destination multicast IPv4 addresses. Now, if you notice here, IPv4 addresses have 4 8-bit octets. The multicast IPv4 address range is from 224 to 239 for the first 8-bit octet, and they're using the last 8-bit octet. If you scroll a little further, it says that the service ID is 4 and the channel is 4.1, and the last two 8-bit octets of this multicast destination IPv4 address is 4.1. Same with this one. As you can see, the channel is 51.1 and the last two octets are 51 and 1. And this goes on and on. The way that ATSC 3.0 implements this is with the last two octets being the virtual channel number. What I can do to look further, because we want to see what the source port and the destination port are, we can go and tap on the packet, and it says UDP, source port 58489 with a destination port of 15101. What this is saying is that for this particular TV stream, the server has an IP address of 127.0.0.1 with a port of 58489 at the broadcast site. And the server is sending this stream to a destination IPv4 multicast address of 239.255.51.1 with a port of 15101. And we can go on further and look at this one for channel 6. As you can see here, from the 51.1 to the 6.1, the source port and the destination ports change. So each TV stream is coming from a unique IPv4 source address and port combination and a unique IPv4 multicast destination IP address and port as well. Now, if you tap on the packet, it'll bring up the hexadecimal, and you can see the majority of this is the payload. So this is the actual HEVC and AC4 audio, and I can change it over to bits to give you an idea. This is literally the bit stream. Let's do a different one that may look more familiar to a broadcast near you is the one that I'm about to do. Okay, so let's do this again, but instead of doing 106.1, we can do a different lighthouse. We can do 110.1. We'll save it to the same format, which is an ALP PCAP. And move that over. Okay. Okay. So it is saving the other WPLG lighthouse stream on RF channel 10. It's creating the PCAP. Okay. It's back. Let's find the file. All right, this is the file. Go back into Wireshark. Okay, so as you can see, this looks a little different, and then we get to the actual broadcast stream here. So for the WPLG Lighthouse, they have a server of 10.106.216.101. This is how they should be implementing ATSC 3.0. It should not be a loopback IPv4 address. It should be a local IPv4 address, and the destination is the same sort of concept here. So as you can see, it's 239.255.10.1 for the 10.1 stream, 7.1 for the 7.1 channel, 10.4 for the 10.4 channel, and so on and so forth. And they're using, just like the other one, the same protocol, which is asynchronous layered coding. Now, asynchronous layered coding, even though it is based off of UDP, there is some forward error correction going on. Even though it is based off of UDP, there are some protections built into the protocol on top of UDP to enhance its integrity. So let's go to 10.1, and you can see UDP source port is 52352. From this IPv4 source address, and then the destination port for the multicast IPv4 destination address is 8101 for this. In my next technical analysis video with ATSC 3.0, I will go into the ATSC link layer protocol and the asynchronous layered coding protocol. But for now, if you're curious where the IP addresses are coming from for your TV streams, this is where they are. This is a relatively simple way of finding this information out. So anyway, thank you guys so much for watching, and I will see you in the next video.